still 4.3, and we are going to solve this one. I went through kind of different types of solving. So the first one I showed you was a 2 by 2. Again, if you see it, don't force it. The second one, we did a little bit of factor theorem synthetic. This one here, I got a little bit of grouping. Right, so it's already got the x minus 3 cubed there. You can expand it if you want. Please don't. Please don't. Those are identical, right? So try to make your life easier. You're not going to finish the question if you're going to do it the worst way possible. And yes, that's part of what we're testing, is that you know how to do a question in a better way, right? If you expand this, you're going to get a power of 4. And yes, you can go back and use factor theorem to factor it, but now you've tripled your time for sure on that question. Right? So if you're going to do the question in the worst way possible, you won't be able to finish. Okay? This is already a common factor, right? It's already got the group for you. So this is common factor. I think I said grouping. Common factoring. So common factored for you. So take this guy out, x minus 3, and you've got 3 and 3. So you can take out 3. Okay, so you've got the common factor already. I think I said grouping earlier. But so common factor from both of those. Leave what's left over. So I took that one out. I have an x plus 1 left over. Plus, I took that one out, and I have an x plus 2 left over. Okay, finish that off. Our beautiful common factor was already grouped for you. If you expand that, you're going to take so much longer just to finish a question. Okay, so if it's already set up, you want to factor in the best way possible. So x plus 1 plus x plus 2, neither one of them need the bracket. So I'm just going to add those two. I'm going to get 2x plus 3. Right? So x plus 1 plus x plus 2 is just 2x plus 3. Go a little faster there. And then again, you're taking each one to get to the root. So this one, I'm going to get x equals 3. And this one here, you're going to get 2x equals negative 3, so x equals negative 3 over 2. So you got your two roots. Okay, so we're going to do a little graph here. Okay, so if it says solve by graphing, you're going to include a little graph. And we go 3, so somewhere here, and again, negative 3 over 2. Okay, again, don't care about the size, shape, or how far apart the dots are, or stuff like that. So just the idea. And we want to graph it. So this one is cubic. Okay, again, you don't have to spend as much time on the actual beautiful shape of it, right? For me, I'm looking for, okay, I know it's cubic, which means it goes through. Right, so it goes through it. This one's linear, which means it goes through. If it's squared, it bounces and comes back. That's the important part I need to know. So other than that, I'll draw it accurately, right? And I'm going to say, okay, I know that this one's cubic. Wait, what's the degree? Degree is 3, 1, 2, 3, and 1. So degree 4, right? You can't do it from here because it's plus, but that's a degree 4 plus a degree 4. This is easier to look at. 3 x's and 1 x, so degree 4. The leading coefficient will be positive, positive, so positive, right? So positive there. So I know it's this n values, so up, up. Technically, it goes through here, goes like this, and then it goes like this, okay? If this is drawn a little messier in this chapter for 4.3, I don't mind, because you're using the idea that it's cubic, which means it goes through. I'll be like, yeah, it went through. Your graph is a little off, but you're getting the positive, negative. The graph that I want is to see if you got the positive, negative part out of it, right? And again, the y-intercept optional. If you want to check it, I would put 0 in. Oh, you have to put, I think this is easier, 0, so it'll be negative 27 times 3, negative 81, so it's down there somewhere. I don't need it labeled. Okay, so it's up to you if you want to include the y-intercept or not. Y-intercept's optional. Okay, I just need this. And again, if you made it a bit messier and went, well, I kind of went through, I knew it's cubic. All I want is this idea is that when is the polynomial above, which is here and here. Okay, so the graph on this can be a little bit easier, a little bit rougher. And then my answer, and again, we're going to do interval. So interval, which will be from there, and it's equal to, so again, look back to the original, greater than or equal, right? So equal, so it'll be square, so it'll be from x is going from negative infinity to negative 3 over 2 square, or a square on the 3 to infinity. Okay, and set would be x is an element of real, x is less than or equal to negative 3 over 2, or x is greater than or equal to 3. Okay. The last question here is if I give you the graph, and it's graphed already, and I did one where it is compared to 0, right? So these are all compared to 0. So above or below the x-axis, so greater than 0 or less than 0. Then in the next example, to contrast, I gave the comparison of the two graphs, right? We talked about at the beginning, right, where I said it's compared to the two lines. So I graph the polynomial and I graph the line. So me graphing it for you saves you a bit of time. Then I don't have to see if you graphed it right compared to the other one. So I graphed it for you. So it means that we all have the same starting graph. And then I asked you when one graph is above the other one, right? So we'll talk about that. So these are kind of the graph questions. So where I give you the graph. So here, when is this function f going to be greater than or equal to 0? This is like two separate questions, okay? So this is, so I'm going to note that down. So I'm going to do this. So it's greater than, okay, or equal. So I want you to almost treat this as two separate. Greater than, okay, greater than or equal. And then we're going to do or equal. It's like two things you're looking for. I want to know when it's greater than it, and I want to know when it's equal to it. So picture it as two things. Okay, so I want to know when the function is greater than, right, the x-axis, or equal. So two separate bits here. Okay, when is it greater than? That would be here. Right? Does that make sense? So that's my greater than, above the 0. Where is it equal to it? Here, here, so that's included, right? And here, got an extra dot. So think of it as two separate questions, and then this is always the question that people get wrong because they forget the equal to, and it is actually two separate things. I want to know when it's above and when does it hit, right? So it's above there and it hits here. So these two just mean there'll be square brackets. So that's the square bracket. This is another answer. So that actually is like, oh, wait, and I have a dot. So this is the one that people forget. You remember it's square, that's the equal to, but then you forget that, oh, whenever it touches, it's also another answer because it's equal to. Okay, so that's the trick. So this is usually the oh, and I'm showing you the trick, but that's the one that people forget, right? You go, oh, equal to. You only look at the greater than square brackets, but technically that's equal to as well, so that should be included. Okay, so that's usually the trick one. Want to do, I guess we'll continue with the, I'll do interval and I'll do set notation. Remember, on a test, I don't want both. You do one or the other. Read the question, and then for me personally, I say do interval if I don't ask for a type. Okay, so then we're going to do interval. I'll do that for all of them. Oh, let's move it over a little bit because I found in the other class I was running out of a bit of room, so let's put it here. Interval, because I'm writing the word interval. Right, so I ran out of room. Interval. And then we'll also do set. I realize because I'm writing the word, so I'm squishing my answer way over. Okay, so for the first one, interval here, greater than or equal. So greater than is going to be here, and then equal means square dots or square brackets. And then I also need to do the dot that's touching. Okay, so we're going to do x as an element of, and it's going to be square on the negative 3. It's going by ones to the 0 square. And then you can use or. I'm going to go back and forth between or and the symbol. So I'll do the symbol this time, or. And then you're going to say at 3. And if it's interval notation, technically, People don't usually like using interval notation, but we go from 3 to 3, which just means there's no interval. It's a solid dot. Okay, it's an interval from 3 to 3, right? And again, I've seen variations. Some people go, I mixed it up and I did set with, and I said x equals 3, but that's not really a interval notation. So this seems to be okay, acceptable. Okay? Then for set, we're going to do x is an element of real, and it's going to go between and here, x, so it's greater than or equal to -3, and then less than or equal to 0, or x equals 3, and you can do that with set notation. Okay, less than or equal. So less than or equal, so this one here was the yellow, right, with the green dots. And then this one here, I'm going to do this green highlighter. So you can see this one a little bit different. Okay, and green highlighter, and it's below, right? So less than, so it'll be this side here, 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 equal as well. So then I also want the green dot. So green dot, green dot, green dot. So the dots that I did there. So yes, I do. So I want this dot here. I'll circle, highlight. So including the dots. So remember, it's 2 questions. This is 2 questions. Less than or equal, right? And treat it like it's a separate question. So or equal is the dots. So then, my question to you is, do I have to do this in 3 separate sections? Do I do 1, 2, 3? No, because this includes the dot. So I'm going to do 1 here, and then this whole thing including the dot, right? So I'm going to include that whole thing. So I'm going to go x goes from -infinity to -3, or from 0, and it includes the dot. So keep going. So it'll be from, square bracket. So it's equal, square bracket. Okay, from 0 to infinity. Make sure your square looks square, so make sure it looks square like that. And, okay, so it goes on to infinity. And including the dot, so it's 1 line, yeah.
Wait, why is it a square bracket of
-3, because it's including the dot. So it's less than or equal. Less than, so include the dot, the equal.
I thought we were looking at the one below it.
Oh, no, so still B, yeah, still B. Right, so this one's the other one where it's not equal. So we want a square bracket, so include dot, include dot, include dot. So we do that. For the set notation, x is going to be less than or equal to -3, or, you can use or the symbol, right? We'll go back and forth. Or x is greater than or equal to 0. All right. Couple more times now. We've got, where's the function just below 0? Only below, not equal to, right? So this one here, this is saying not equal. So I want only below, so below, 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 but don't take the dots. So not the dot. So not the dot, right? Not the dot for C. Does that make sense? So not this dot for C. So it's going to have to go from here, don't touch the dot, and then keep going. So that means I'm going to have to break this up into 3 parts. Below, below, don't touch, and then below. So I'm going to do 1, 2, 3 answers there. So we're going to go, x is going from, and this will be -infinity from -3, round. Round. I'm going to highlight that, round here, right? Or, so or, and it'll be from 0 to 3, close it, or from 3 to infinity, right? And these are all round because it's less than but not equal. So you can't include the dot. I'll make this a star. Okay, so not for C. Set notation, it's just long, so it'll be x is less than, not equal to -3, or x is between 0 and 3, or x is greater than 3. Yep.
Could you also do the set notation, like x is less than -3, or x is greater than or equal to 0,
Not
equal to
Yes, I was going to say yes, absolutely. You can say x is greater than 0, right? And then you would say what?
and not equal to.
And x does not equal 3. Okay, so then you could do that instead of breaking it apart. So it's be greater than that and x does not equal 3. Okay? All right. That's why, yes, you can do that. You can do that with a, kind of that restriction idea. Yeah. Okay. Here, wait, the word and, though, I'm not liking that. Yeah. Sorry? No, I know, but and means that they're supposed to be all at the same time. So then this would be or. So x is less than -3 or greater than 3. I'm wondering if it should be comma, because and means at the same time. So I'm thinking comma, x cannot equal, right? And is not.
No, it is because it's greater than 0 and at the same time not equal to 3.
And at the same time here.
Could you use like brackets? Well,
Brackets?
Because it's like that, isn't that a separate thing? The or like separates it?
No, the or is separating it, saying that it's this line and that line. But remember, it's two separate lines. And means it's supposed to be at the same time. So I'm not sure if we should use the word and.
It's when x is greater than 0 and x does not equal 3 at the same time, which is every number that's greater than 0, that's not 3.
And does not have that same meaning. And remember, in inequalities means that we're saying it's greater than, so say I have 2 and I have 3, and I say it's greater than 3 and greater than 2, it's only where they overlap. So and in mathematics means it has to be at the same time. How can I be not equal to 3 and greater than 0 at the same time?
Isn't it just every number that's not 3? 2, 4?
You're thinking of it in terms of language. English language says that and means that I want them both happening. This is mathematics where we're saying I want them both happening at the same time. I can't be not equal to 3 and also greater than 0.
What if you were to draw not equal to 3 on a number line?
Okay, so on a number line. So on a number line, you want what?
Draw x doesn't equal 3.
What's the rest of it?
Wouldn't it just be
Like
infinite both ways?
If you draw x doesn't equal 3,
Just
wouldn't it
pull
just
it.
be
Yeah, so it's
infinite
this.
both ways, then
So
all
not
3?
equal to 3.
Okay, and then draw the x is greater than 0.
Okay, which is going to be 0.
And then where do they overlap?
With the or of the other statement.
Oh, is that the problem?
Yeah.
Or the other one? Oh.
Because then what do I do with the or? Because now I've got the or of the other statement, so I've got the -3. So I'm not sure if we're allowed to combine.
Does the and apply to both of them?
That's what I'm wondering. That's what I'm wondering. I'm like, I'm not sure if we can do this part. This was okay for a second, but I'm like, wait, this is or, and then this is and.
Wait, but doesn't it still overlap? 'Cause the-
Yeah, so it overlaps here,
Does it
overlaps here.
Overlap on the left?
But we're
Does it
putting the
zero
or, hang on,
still up?
hang on. But I'm just saying with the or here, because we've got this or this, and this is the end, but the end doesn't reply to that. Let me look to make sure that that makes sense. That we're allowed to put an and and an or in the same statement. Or what will happen, what we'll have to do is break the set and do one set here and then another set for the other one. Because you know what I mean? It's like order of operations, right? So it's like order of operations. I'm thinking that I have to close the set here, put or, and then do a set here for the end part. right? Because it's the and and the or, because I think by or, it's that order of operations idea where I've got an and and an or in the same one. The and only applies to this one, that's fine. But this now is contradicting that part. So I think I would, if I wanted to do it like that, I would close this one up, put the or, and then have a separate set for the part that you were saying. Does that make sense? Yeah, so then close the set, or open a new set, and then put the other statement. Yes. Yeah, okay? So if I just confuse you, just do it this way. But yeah, that definitely works. My problem was with the or and the and I'm like, now I think we've just contradicted each other because we've got an or and an and in the same. So I would close it up, do greater than, but it's not, right? Not equal to, and then have this as a separate set. That way they're not trying to combine each other, right? Because you're saying the and goes with this one. Right, so that's fine because it's overlapping, but the or is the other part. So yes, that's why. So I would do a separate statement for this part. So x is, so let's write that down. So we have that concluded. So I would do this, x is element of real, and then x is less than -3, or, and then you could do a new set, x is element of real, and then have your other set, right? So x is greater than, what am I doing? Greater than 0, and x cannot equal 3, like that. There you go. Does that make sense? Good? Yep. What do you think? Yep. I'm sorry, what? The not equal to? Yeah, that doesn't fit. Yeah, interval notation doesn't have a not equal to. Yeah, so interval just likes to break it up. Interval is always saying the parts that it exists at. Yeah, so interval does not like this, so please don't use that with the interval notation. Yeah. Okay, because then you're mixing the two types of notation. Yeah, so I'd feel better, yeah, if we put the or as two separate. Does that make sense? And then it's like order of operation, so I'm not merging the two. Okay, good. And then this last one, I gave you the graph, and I'm asking for when one function is above the other. Please excuse my graph. I'll do better if it's an evaluation. These were supposed to be exactly on the dots, and my graph shifted a bit, so that should be at intersecting at -3, at 2, and at 5. My graph shifted a bit there, okay? So please excuse those, but that's the intersection. So this is asking you, when is the f function, which I said is the line, okay? When is the line, okay, above the polynomial? Or, alternatively, you can read it from right to left. When is the polynomial below the line? Okay, so either way you read it, you get the same answer. So if I say, when is the line, f of x, the line, above, look, and I have them labeled, above the polynomial. So the line is above the polynomial here and here. It's two questions, so please treat it as two. So greater or equal, okay? So the equal part would be dots as well, right? So dot, 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 so including the dot. So when is it greater than or equal? And then again, let's do interval and set so we can discuss both. So this will be interval. Okay, so for my interval, it'll be from the -3 all the way to the 5. So then it'll be x as an element, and it's going to be from -3 to 5, like that. Okay, including the dots. So no break there. And then for my set, it's going to be from x as an element of real, and then from -3 and to 5. So that's pretty straightforward. Okay. The next one, again, let's put the interval here on the side because I'm running out of room, and then set, just because it's squishing my room. Okay, so then, when is either the lines, you go f of x, below or equal, right, so it's two parts of the question, below or equal to the polynomial. So when is the line, so this question here is the yellow here, I highlighted there, and I'm going to do green here. So when is the line below the polynomial, or you can say when is the polynomial above the line? And I see a below here and here, right? And then go back and do the equals like a separate question. So equal would be dot, right? Dot, dot. So it's like two separate questions, below or equal. Okay, it's two separate things. So if you treat it as two separate, so it's below, so less or equal. So do the equal separate. That's usually where the only place where people make a mistake is that they forget the equal to. Okay, so then that would be here and here, including the dot, right? So they're just going to do the notation. So x is an element, and it's going to be negative infinity to negative 3 square, or at the 2, so 2 to 2. Okay, or, and it'll be from 5 on, so square on the 5 to infinity. Okay, and set, it's the same thing. I think we're getting used to this. It'll be x is less than or equal to negative 3, or x equals 2, or x is greater than or equal to 5. That makes sense? So equal to is like a separate part of the question. Greater than or equal, less than or equal, treated as separate. And that contrasts with this one. So just showing you the contrast. This one here, interval for this one is only less than. So it's going to be the same question, but only this part without the circles. So only less